Hey everyone, so here's the other half of section 10.2 notes. Again, it's still special right triangles, but these triangles, this is called a 30, 60, 90 triangle. 30, 60, 90 triangle. And a 30, 60, 90 triangle kind of looks like this. Well, it does look like this, but then the triangle can be turned around, so sometimes looks like this. But we know, based on the angle measures, that it's a 30, 60, 90, and they'll always be in there if it's a special 30, 60, 90 triangle. That's how we're able to identify it. Remember, the side across the right angle will always be the hypotenuse, and then these two are legs. But in order to distinguish between the two, the smaller angle, which is 30 degrees, the leg opposite the smaller angle, they call this the short leg or the shorter leg, and then the angle across the 60, or the side across the 60-degree angle, like this side going across this way, that's called the longer leg. Okay, I'm just going to put on here long leg. So that's how we know the difference between which leg, because you can't, unlike the 45, 45, 90 triangle, those two legs are the same measure. You can just say the leg there because it's the same on both of them. These two are not the same. So again, if you look at this one, I know, or we know, this side is going to be the hypotenuse, and I'm going to abbreviate it like this, and then across the 30-degree angle, we're going to have the shorter leg, and the shorter leg I'm going to abbreviate as SL. I'm like you guys, I want to write as the minimal as possible. And then across the 60-degree angle, go across the 60-degree angle, that's going to be the longer leg. Surprise, surprise, I just put LL. Okay, copy that, and then we'll see what the special property is. So this actually has two equations. One of the equations, it says the hypotenuse is twice as long as the short leg. So I kind of abbreviate it like this. Hypotenuse equals 2 times the short leg. That's exactly what it says here. And the other equation is the longer leg, or the long leg, is the length of the short leg times the square root of 3. So this is LL long leg equals the short leg times square root of 3. And all of that information is in the diagram. So if you look here, the 30-degree angle, if you go across from it, this is the short leg. So the hypotenuse is 2 times the short leg, that's what we said here. And then this is the longer leg. The longer leg is the short leg times the square root of 3. Okay, so pause this if you need to pause it. I'm going to flip it over and do some examples. So here's our, we're only doing 2 examples. So here's the first example. So for these, we're going to figure out, we're still trying to find the sides of the missing sides of a right triangle. But because we only have one side, we can't use the Pythagorean theorem like we've been using before. But we can use the special properties of a 30, 60, 90. What I like to do first always is to identify what the sides are. Like this one is the hypotenuse. And then since this guy right here is 60, if I go across this way, this one must be the longer leg. It's the longer leg because it's across the bigger angle. And then 30 and X, this makes this side the shorter leg. Alright, if you go down this way, so that's the shorter leg. So across the 30-degree angle is the shorter leg, and it's the shorter leg because that's the smallest angle. And then across the 60-degree angle, it's the longer leg, and of course across the 90-degree angle is the hypotenuse. So that's its hypotenuse. And then if I put in the 2 equations that I just had a second ago, the hypotenuse is 2 times the short leg, and then the longer leg equals the short leg times the square root of 3. Then we're able to figure out the information from in here. Okay, so I know the hypotenuse is y, so instead of hypotenuse I'm going to put y. and then the short leg is x. Okay, so if I substitute that information in here, I get this. I can't do anything with that yet, so I'm going to go to the next equation. So the longer leg, there's the longer leg, it's 9. Okay, and the shorter leg is x. Okay. Now with this, I can solve for this. I can solve for this because I only have one variable missing. See, on this side there's 2 variables, but I can solve for this one. Now here I have 9 equals x times the square root of 3, and we want to get x by itself. So what we would do is the inverse, which is divide both sides by the square root of 3. That goes away. Then we have x, and what we have is 9 over square root of 3. But remember, we cannot have square root of 3s or square roots in the denominator. So what we have to do is multiply the top and the bottom by the square root of 3. And when I do that, I get 9 times the square root of 3 on top. And then on the bottom, this simplifies into 3. And then we're not quite finished yet. Let me show you how this simplifies though. Remember, the square root of 3 times the square root of 3, that's the square root of 9, which equals 3. Okay, that's a little side note. Okay. So that's where this 3 came from. And then the last thing we need to do is divide these. If you look, you have 9 over 3. Remember, 9 over 3 is just 3. So we have 9 divided by 3 is 3, and then we still have this one left over. So I know x is this value. Now I can put that value into this equation to figure out y. So watch, I'm going to substitute 3 times the square root of 3, because I just figured out x was 3 times the square root of 3, so I'm going to put it in here. Right? And although this one was kind of messy, this is easy. All you have to do is multiply the 2 numbers in the front, and we get y equals 6 square root of 3. And I figured out what y and x is for this 30, 60, 90 triangle. Okay. So let's move on to the bottom example. So this is the bottom example. Again, the first thing you want to do is identify the sides. This side is the hypotenuse. The hypotenuse is y. Across the 60 is x. So this is the longer leg. So this one over here must be the short leg. Okay. Write down the 2 equations from the notes. The hypotenuse is 2 times the short leg. The longer leg is the short leg times the square root of 3. And then substitute the values into the equation. The hypotenuse is y. So the hypotenuse is y. The short leg is square root of 3. So the short leg is square root of 3. And then over here for the long leg, I'm going to put x. The long leg is x. Short leg, square root of 3. Here it is here, short leg, square root of 3. And then bring down that square root of 3. And then I can solve for both of these. On this side, there's nothing to do with this side. That just simplifies into 2 square root of 3. And then on this side, we actually just simplified this up top. But remember, multiply those 2, you get the square root of 9. And then the square root of 9 just comes out as 3. And then that's what x equals. Okay. So A was a little bit easier, but B was not too bad. As long as you identify the sides first and then plug them into the 2 equations, you should be okay. Next time we meet, we'll do some practice problems.